Okay, so let's move on to the new handout, which is reflections symbolically. Right, so in part one, reflections, we examined how types of reflections, two types of reflections from a graphical point of view. For reflections across the y-axis, right, this way, and reflections across the x-axis, this way. Now we're going to take a look at it symbolically, right, in terms of, so now you know what they do in terms of looking at it. Now we're going to take a look at it in terms of, you know, the actual function, kind of what's going on. Recall, to reflect a graph across the y-axis, right, this way, guys, what happens? Does my x change or my y change?
Y.
From here to here? From here, I go to there.
Your x changes.
My x changes, right? My y stays the same. It's across the y-axis, the y stays the same. The x becomes negative x. So, remember we talked about this. AB becomes negative AB, right? A comma B. So, for example, 3 comma 2 would become negative 3 comma 2, right? Here's 3, 2. If you go over here, everyone on board? Right, 3, 2, negative 3. Okay, so what happens is x becomes negative x. Everybody on board? So it's actually kind of just as simple as that. What we do is we have y equals f of x. It becomes y equals, the new function would be y equals f of negative x. So in other words, here's an example. I have f of x equals x plus 1. I'm going to change that, and everywhere I see, I'll call it g of x. G of x. Everywhere I see x, I'm going to swap it out with negative x. So I'm just going to rewrite this, and everywhere I see x, I'm going to put a giant parentheses, and instead of x, I'm going to write in negative x. Does that make sense? Because my x becomes negative x. It just changes sign. Is that see what I'm saying? So everywhere I have an x, I'm going to change the sign of x to negative. But I'm going to put inside parentheses. That way if it's squared, you know, a negative, if you square a negative, it becomes positive. And the same thing will happen with, you know, the x stuff. So wherever I see x, I'm going to put parentheses. I'm going to just replace it with negative x. So I want you guys to really get used to this idea of putting a parentheses in for stuff and then just replacing it with whatever, with something else. So here I'm going to replace x with negative x. I'm going to swap it out. Substitution. Okay, so let's simplify that. How do I simplify that? When you have a parentheses, you need to see if there's anything acting on the parentheses. There's two places it could be acting. I could either be multiplying something in front of it, or I could be raising it to a power. Am I doing either one of those things?
No.
So now I can remove it if I want to. So those are the rules for when you can remove a parentheses. People get lost on that, confused on that a little bit, right? If you have nothing acting on it, nothing being multiplied in front of it, nothing, not being raised to anything, then you can remove it. So I'm going to remove this. So this becomes, it's not the same function, it's a different function because it's the reflection. So I'm going to call it g of x is negative x plus 1. All right, so what they did was they just did f of negative x, right? So they put negative x everywhere the x was, and then they call it something different because it's a different function. So we're going to do that. You can double check, right? So they kind of went through some double checks. We're not going to bother with that, but you know, you can kind of you can see that if we did do that, here's the f of x, here's the g of x. So you put in these numbers, -1, 0, 1. Here's your y's, and you'll see that you get the points 1, 2 should become -1, 2, right? And the point -1, 0 becomes the point 1, 0, and then the point 0, 1. Remember, the x becomes negative x. Negative 0 is the same thing as 0, so that stays the same. So this one went there, right? This one went there, and that one stayed the same. Okay. And then here are the two reflections. You can see them if you map out those points. Okay. So we're going to do all these things. First, we're going to find the symbolic expression that represents a reflection of the function in the y-axis. So we're going to reflect it across the y-axis, which means that x becomes negative x. We're going to replace x with negative x. Then we're going to make a table of values, just 3 values for x and y. Pick 3 values, like 0, 0, 1, 2, or something like that, or -1, 0, 1, any one of those will work. And then graph the new function, and then confirm that it's a reflection of this first function. Okay, so I want everybody first, this one here, all of you guys, rewrite this, replacing x with negative x. So you're going to rewrite this. I'll do it this way. F of, I'm going to put a big parentheses where I see the x. Everywhere I see x, I'm going to put a giant parentheses. So F, giant parentheses, equals 2. I see an x. What am I going to write instead of x?
Negative.
Giant parentheses. -1. Then I want you guys to put in negative x here, which means negative x goes there. So are you guys kind of following me? So that's the best way of substituting for x. Whenever you see x, put a giant parentheses. Write it all out, and then plug in whatever goes there. Whatever goes there goes in all the parentheses.
So what goes there?
I'm sorry?
You're saying whatever goes there, but what
Whatever goes here, I'm going to put in negative x here. In this case, I want to substitute in negative x for x. So I'm going to put in negative x here. Well, I'll put negative x in there.
But you're just making it up at this point.
No. So
Like you just made up a negative x for this. There's nothing in the problem that tells us that we're substituting negative x.
yes,
Yeah.
because we're reflecting across the y-axis. So anytime you reflect across the y-axis, x becomes negative x.
Oh, reflecting across the y-axis.
Yes.
Oh.
So now, everybody simplify this. Is there anything acting on this parentheses? Yes, it's been multiplied by 2. So you got to multiply it by 2, and then you can remove the parentheses. So everybody do that. Simplify this. Simplify that. How do I simplify this? Multiply it, right? 2 times negative x. So if I have a negative x and I multiply it by 2, I have 2 of them, then how much do I have? Multiply this. How do you multiply this? So think of x as an object. So what do you guys want x to represent? A cat, car, baseball cap. What do you guys want it to represent?
Car.
A car? Or a skateboard. We'll do a skateboard. You guys are so quiet. All right, so x represents a skateboard. Negative x means I owe somebody a skateboard. Everybody on board with me? Negative x means I owe. I owe you a skateboard. I'm going to multiply that by 2. Now what happens? I owe 2 skateboards. How'd you write I owe 2 skateboards? Negative 2x. Does that make sense for folks?
What was that?
This becomes negative 2x. Now I owe you 2 skateboards. And I also owe you $1. All right? I owe 2 skateboards and $1. Now look through there. Are there any like terms that I can simplify? Are these like terms or different terms? Different. That's $1. That's a skateboard. Not the same. Good? All right, so now we're going to pick 3 numbers for x. I'm just going to pick 0, 1, 2 because I'm boring. So put 0 in for there. Or you know what? I'll do, that's right. So I put 0 in there, so it becomes, when x is 0, this becomes 0. So that's negative 1. I put 1 in there for x. So maybe I should model that too. Right, this is negative 2 parentheses minus 1. I put 1 in there. Then this becomes negative 2 times 1. Negative 2 times 1 is what?
Negative 2.
Yep, negative 2 minus 1, which is negative 3. I owe $2, I owe $1, altogether I owe $3. Next one, negative 2, and I'm going to put in 2. So negative 2 times negative 2 is negative 4 minus 1, and I get negative 4 minus negative 1. I owe $4, I owe $1, altogether I owe 5. And then since I'm here, I should have done this one. We'll do negative 1 also. Negative 2. We'll do if I did negative 1. So negative 1 in there, when x is negative 1, what do I get? Negative 2 times negative 1 is, positive 2 minus 1. I have $2, I owe $1, altogether my net worth is positive 1. Okay, then graph them. Everybody graph these. 0, negative 1. Oh, that's already graphed. It's right there. 0, negative 1. Okay. How's the next one? 1, negative 3. Where's that? I start off at 0 at the origin. I walk to 1. And then negative 3, I go down. I take the elevator down. 3. Negative 3. Right there. Next one. 2, comma, negative 5. I start at 0. I walk 2 to the right. And then negative 5. Do I go up or down? I take the elevator down to the 5th floor. 1, 2, 3, 4, down here. The next one, x is negative 1, so I start out at 0, I walk back to negative 1, and then my y is 1, I take the elevator up 1, so I'm right there. And I'm going to draw my little line through this. And there we go. Draw your line.
You go all the way off the graph?
Yeah. So, you guys have 2, 3, 4, and 5 to do. I just did the easy one, sorry. Oh, here's the thing. Number 2. When you pop it in here, you don't have to simplify it. Just leave it as whatever in parentheses squared. Don't simplify this. Do you guys see what I'm saying? So you're going to end up with something in parentheses squared. Just leave it like that. Everybody all right with what I see what I'm saying? If you're here and you've got it cubed, you can totally cube that one. That's fine. You can simplify these two. And the third one, this one, the 5th one. You can simplify those. But this one here, just leave it as, whatever that ends up being in parentheses squared. That's totally fine. Okay? Good? Okay. So hop in with your groups, and we'll take about 10 minutes to work on those, maybe 5 minutes, 10 minutes. So this one, right, we're going to do f of parentheses equals, and then I have an x. So I'm going to put parentheses where I see the x. What goes inside of there? What am I replacing x with?
Negative x.
Negative x. So then my question is, this first inner parentheses, is there anything acting on it?
No.
No, there's nothing being multiplied in it. It's not being raised to a power. So this inside parentheses, I can remove that. Everybody on board? And that should change this to g of x. So then g of x equals negative x minus 1 squared. Okay, so then I just done most of the hard work for you. Find your thing. And then, as you sketch this, you can sketch it first if you want. See, this one is 2 to the right, becomes 2 to the left. This one's 3 to the right here, becomes 3 to the right there. So it kind of goes down like this. And this one is 1 to the right, one left, one to the right. So you can sketch it, and then I can see, oh look, I'm going to want to pick -1, -2, and 0. Right, it kind of tells me what to pick, kind of in a way, right?
Why are we changing it to G? No? Right there?
Why are we changing what?
Why are you changing the F to a G?
Because it's not the same function.
Oh, okay, so you can randomly pick a letter? Anything?
Well, but it should be F, G, H. Pick one of
okay,
those.
one of those two.
Yeah.
Okay.
Yeah. And shall I let you guys cheat? If you want, I can let you guys cheat a little bit, and you can just find the points here. -1 goes with what? What's my y? And then you can just pop them in there. That's okay too. I'm okay if you do that. Yeah. I'll let you guys do a little shortcut. It's a little cheating, but that's fine. Totally okay.